Hello and welcome to another video. Today we're going to be talking about Kp, which is the constant relating to pressure. For Kp we use something called partial pressure, which is the pressure exerted by one gas in a mixture To calculate partial pressure, first we need to calculate the mole fraction, which equals number of moles of whatever you're using. We'll call that A over total moles. Then times your mole fraction by the total pressure, which equals PA. P is partial pressure. Let's do a worked example of working out partial pressure. So let's say there is a mixture of 3 moles O2 and 4 moles CO, and we're trying to calculate PO2. First, what we do is we and total pressure (1 kPa), so it's just 1 kilopascal. To work out the partial pressure, we will first calculate the mole fraction, which equals O2 over O2 plus CO, which equals 3 over 3 plus 4, which equals 3/7. Then you times the mole fraction times total pressure, which equals 3/7 times 1, which equals 3/7. Sorry. 3/7 of a kPa. Normally you'd give partial pressures in decimals, so 3/7 in decimals is 0.429 kilopascals. That would be sort of the way to calculate partial pressure of anything in a mixture. Do you want to calculate the partial pressure of CO? Have a go. Pause the video. Yeah, so that's going to be 4/7. So just a little quick side note. Partial pressures should all add up to total pressure. Now, to quickly talk about Kp. So Kp equals, for say a reaction HB goes to B plus H, all of which are gases. So that's the reaction. Kp equals Pb pH pHb. That's Kp. Remember here you have to put the lowercase p outside to indicate that you're talking about partial pressures, and you need round brackets as opposed to square brackets that you would have had with Kc. So lowercase p. Also, for this, all species have to be gases. So again, you could still have more complex questions. For example, like we talked about with the KC ones, you could still have rice or ISA questions, ISA calculation questions to do, and I'll talk about that just a little bit later. So, cool. So first you just, once you've worked out the partial pressures, plug the numbers into your equation or into your expression, and you should get the final answer or final value. A note for Kp, all units have to be consistent. So you can't have some in pascals and some in kilopascals. So they all have to be in one unit. And in order to calculate the units, all you do, so let's say again for the HB goes to B plus H, you just put your units in as you would have done for Kp. So let's say they're all in kilopascals. Cancel, and then just, that's your final answer. So again, with Kc, you sub into expression, and then you cancel, plus simplify. Okay, let's do a worked example for one of the ISO questions, and then I'll give you one to go for yourself. Yeah, so, sorry, worked example. You have 2 moles of nitrogen at the beginning, 3 moles of hydrogen at the beginning, and at equilibrium you're forming 1 mole of NH3. So you set it up as you would have done for the ISA for Kc. So you're adding 1 there, you're taking away a half there, so it's 3 on 2, and you're taking away 3 on 2, which is 3 on 2. That's your equilibrium moles. So Pn2 equals your mole fraction, which is 3 on 2 plus 3 on 2, which is 3, plus 1, which is 4. So it's 3 on 2 divided by 4, which equals 3 on 8, times by the total pressure, which is 6. 3 on 8 times by 6, 9 on 4, for P pH2, it's the same thing, 3 on 2 divided by 4, equals 3 on 8, times by 6, which is 9 on 4, and pNH3 equals 1 divided by 4, which equals a quarter, times by 6, which equals 6 on 4, which is also 3 on 2. Plug that into your Kp expression, which again you need to remember your stoichiometric coefficients. 3 on 2 squared over 9 on 4 times 9 on 4 cubed, which equals 64 on 729. And your units, so you have 2 kilopascals, kPa squared on the top, and kPa to the 4 on the bottom, because you have 2 and 4. You can cancel that, so it's kPa to the minus 2 as your unit, and that should be your answer at equilibrium at that particular temperature. Because again, like Kc, Kp is only affected by the temperature, not by pressure, or not by changing anything else. Cool. Have a go with another question of yours. So the equation is the question is CaCO3, which is a solid, goes to form CaO solid plus CO2, which is a gas. The PCO2 equals 2.5 times 10 to the minus 2. Calculate Kp. Pause the video, try and work it out for yourselves. Cool. As you know, only gases are included in Kp. So this one is quite simple. There's only one gas. So Kp equals PCO2, which equals 2.5 times 10 to the minus 2.5 times 10 to the minus 2. And the units would be atmospheres, and you can just keep the units at whatever the units are. That's it for Kp. It's pretty much exactly the same as Kc using partial pressures. The important things to remember are the formulas. So mole fraction is the moles of whatever you're trying to calculate over the total number of moles, and partial pressure is the mole fraction times by the total pressure. Thank you for watching. See you tomorrow for another video.